I guess I can take this opportunity to test out screen sharing here, and we'll see. Okay, can you see my screen?
Yeah, totally.
Okay.
You're using what is that? What's that color scheme? Solarized.
Solarized dark.
Yeah, that's my favorite. But you have that working in Emacs. I didn't think that worked in Emacs very well.
Yeah, it actually works great. Emacs now has a pretty decent theme engine.
But you're not using the terminal version, right? I don't think it works in the terminal version of Emacs.
No, I use the X version, and I actually use Xmonad as my window manager, which is so basically it makes it really easy to handle screen layout like that. So I basically let the X Windows handle all of the window layout stuff.
Yeah, I do that sort of thing with Tmux. Tmux, I don't know how you pronounce that.
Right. Tmux is usually what I've heard, at least. Let's see, this is the annoying thing. So this, instead of opening it up in a new frame, it splits the window and leaves the other one up. So it's just very annoying. So that's the... So yeah, I mean, org mode is sort of the one thing that you can't get a suitable replacement for outside of Emacs.
Right. I haven't found anything that's quite as good as the Emacs version.
Well, and stuff like this, this literate programming stuff is just great. So I mean, you've got all of the so basically, you get the font locking for the specific languages they're embedded, and then this here is the. So then I can export that as PDF easily, and everything's typeset nicely.
Cool. It's like a textbook.
Yeah, you can always spot something that's been made with LaTeX. And let's see. And I think I posted somewhere, if on the event page on YouTube there. Let me get the URL. Here we go. Link address.
Okay.
There we go. Oh, infinite.
Yeah. How does that happen?
What's that?
How does that happen?
Because I'm sharing my screen, and so I'm currently looking at the display window. So.
Got it.
Oh, that's trippy. Okay. So that's an HTML version of my exercise solutions that I posted there if anybody wants to look at them.
Okay.
And with anybody else who's joined, I think at 7:30 we'll just say, okay, that's it. Whoever's here is here.
Oh, okay, cool.
And that's also, so that's basically if I can just export from this, org mode has great export features. Oh, God. Okay, except that's one thing that's not working correctly on this machine for some reason I cannot fathom. There's a strange bug that it can't pop up certain windows. So maybe it's this. Nope, that's not it. So anyway. Ah, there we go. Okay, it's a full screen problem of some sort, it looks like. It's a bug in org mode itself. So if I pop this open here, so you can see I can export it to any of these formats here, and it's very nice because okay, let's shut this down again here. So things like typeset, like this here, gets typeset as nice mathematics. And if you know LaTeX, it's almost as easy to write that as to write down just any mathematical expression. So that gets typeset as that right there.
Cool. Yeah, I've just been using just regular text, regular ASCII text for that sort of stuff. Well, UTF-8, whatever it is.
Right.
But nothing. But that is beautiful.
Yeah. Well, but I mean, when you start doing things like this, you can actually get the the correct layout for all this stuff, and there's a very tidy notation for it. So if you write any papers for a graduate program, you get familiar with this pretty fast, or you have a really, really miserable time trying to do it in Microsoft Word or something. Microsoft Word's equation editor is just barbaric. Oh, and looks like I've got a couple of typos there. No big deal. There's some really spiffy things, though, with the org. TM asked me to give a talk on this, so I'll be giving a talk on org Babel, which is this mode for embedding text inside of a org mode document. And the cool thing is, let's see, results. So all of these things here are specified with this session here. So they're run in a persistent scheme session behind the schemes. And so each of these chunks of code slowly builds up over time, and they can reference the previous one. So this silent means it's not going to stick anything in the document. Let's see here, what do we have? So right here, for example, here's the code. So this is just this particular line of code. Exports both means it's both going to insert this code block formatted neatly into the final document, but it's also going to include the result of evaluating that code.
Oh, that's pretty cool.
Yeah, and you could actually do really cool stuff with linking this together. There wasn't a lot I did with this particular set of exercises, but in like 1 and 2, like I was feeding output of one block to a shell block to format it and stuff like that, just because you can, So like this here, so it's it's running this function through a bunch of options that just runs through a range, and so there's the output, and so then that's 129. So, and that's how it ends up. So that's the so basically you don't have to. This is not a static part of the document. So you can recompile that org file, and it'll recalculate all of these results.
That's pretty cool.
If you've got something that takes a really long time to calculate, in that case, you can cache the results, basically. Then if the code block hasn't changed, it won't actually recalculate it.
Cool.
Okay, double check to see if anybody else is watching. Nope, nobody else is watching, so I guess it's just the 3 of us tonight.
All right.
Okay, that's fine, I guess. So how did everyone do on actually working through the exercises and the reading?
Well, I actually got through all the exercises and the reading. I thought it was actually a lot. This section was the most, so far was the most enlightening in terms of, okay, this is the sort of stuff that you can really do with these. I mean, there were essentially 3 things that you learned, 3 important things. You learned that you can pass around functions as arguments. You learn that you can so functions can take functions, functions can return functions, and you learn that you have these special forms, the let forms for binding, internally binding some special cases. So I mean, I just felt like with those 3 things, you pretty much can do a lot of stuff. So I don't know what anyone else thought, but.
Yeah, I guess not to sound too simplistic, naive, whatever the right word was. I really like the analogy with Sigma notation. You know, we've all been using higher order functions since whenever that was, 7th grade or so.
So you mean summation, basically?
Yes.
Yeah.
So the idea that we can separate the iterating through a set from the operation on a set, and probably was a good thing that when they introduce it in grade school, they don't refer to it as map and fold functions, because that may not make it easier for kids to really get it, but it's just always been there. And I think that it probably, I think it's an interesting question. It probably would simplify things once you got to some point in calculus to actually formalize that representation. But I think what was the line? It's in section 2.1 where I'll quote the line: "We're using here a powerful strategy of synthesis, wishful thinking."
Right. I love when he says that, because it's like, it's like, oh yeah, you can. A lot of this stuff really is wishful thinking, and if you start off that way, it's like it's pretty amazing how the interesting things that you can build using that perspective. I've kind of actually been there's this whole debate going on right now whether TDD is dead, whether it should be, and I thought that someone because I was watching the class, the video that was given in the 80s for this chapter, and I thought that it was very applicable because someone actually asked, well, how do you know about those people who say that you should always design your work before you do it? And he talked a little bit about how it's not always like that. That people who think that designing all of the work beforehand haven't really worked with very large systems. But I feel like when you hear him, he talks, on the one hand, he talks about not making these sort of super design strategies, but on the other hand, he also talks about wishful thinking. So it's like two, so there is some kind of design, but it's not. It's sort of like an overall kind of stepping back sort of thing. And I feel that with TDD, that's kind of like there is that aspect to it. Like is TDD driving too much of the design? Is it actually trying? Is it sort of making people make decisions too early? And versus all kinds of things. Just like listening to these videos and keeping that sort of thing that's going on right now, I thought was really interesting.
Yeah. So just out of curiosity, how much experience with like functional style programming did you have before coming to SICP? Is this your first real sort of time that you're tackling these?
It is my first. Well, I picked up Clojure right before starting this thing, but the thing about it is that because I've been working with JavaScript, and I know I keep saying that JavaScript does have that kind of functionality of being able to use higher order functions, and pass them around and that sort of thing. And Ruby sort of not quite as much as JavaScript, but has it in terms of the blocks. The blocks are a little bit sort of like passing around functionality. That said, it's the first time I've actually gone, at least with this chapter especially, the first time I've actually seen it being practiced, kind of used, like, okay, this is really what you can do, sort of building up. And this chapter and the next chapter, actually, the next section, building up sort of the power of like behind this stuff, using the infix, kind of like building these abstractions on top of abstractions on top of abstractions, and very quickly designing a completely different language just by doing that. So it's really the first time I've seen that, and I think that I'm not quite sure that maybe it's just because math kind of lends itself to that sort of ease of use of taking something like scheme and writing these sort of patterns that we know about, mathematical patterns in a programmatic format. Like, I feel like, well, maybe they're cheating because they're using a lot of math examples, and so it's easier. But I can see, like with some more practice, being able to apply this outside the math world.
Well, I think I welcome everyone else's thoughts on this, but I think at some point we should look through Paul Hudak's School of Expression book and look at how he represents both graphics and music.
Is that the Haskell School of Expression? Is that the
yeah,
yeah.
Because it brings this into a totally different domain, and it's I think it addresses that question. A functional approach is really there, and I would love it would be interesting to reread this. My first connection to not really functional programming, but specifically functional data model was my first day working for CCA, which, believe it or not, was July 11th, 1983. So dating myself a little bit there. David Shipman wrote an article on the functional data model, maybe Daplex functional data model, and it just blew me away in a functional representation of persistence. And I don't know if you were trying to find that reference, but it would be cool for.
I'm making a note for later so we can.
Yeah,
share
it'd be cool to find it and see if it's as compelling now. So I think even though the examples are really artificial, in fact, one of the things that threw me off of 1.3 was I don't remember the specific exercise, and I think this was in 1.3, was trying to figure out how frequently you needed to call the averaging function depending on the power. And I was just like, I'm going to hack and just look for somebody else who figured out the math behind it, because I don't want to spend that much time on the math. So I understand that you sort of get caught, how much is this math domain, but I think the power is really there overall. And just to plug another reference, look at the any presentation on Ohm, and you really see the power of functional programming put into the user interface.
Yeah, I want to get somebody to talk on Ohm to Clojadelphia, because I think that would be a really interesting. I think Hunter has been doing a lot with that.
Yeah, he's been, I think, posting stuff, or at least he's been starring things on GitHub. So I'm assuming that that he's got to be into Ohm right now. I only just recently found out that Ohm is actually a ClojureScript sort of wrapper for React.js. And I actually was very interested in React.js because I think that conceptually, I've seen a couple of videos on what they're doing, and I find it amazing. I find it really interesting. So I really like the idea of trying out Ohm sometime soon.
I think it's consistent with this whole philosophy. Is, I guess, the point I was trying to make is that stick with this. I think you'll really find it's this idea of immutable, no side effect, functional programming has just really broad applicability.
Right. All right. So should.
No, go ahead.
Oh no, I was just going to ask if we should go through the problems, or just philosophize for.
Well, I mean, whatever you guys want to do here. So, Mort, did you tackle the? I guess you tackled a bunch of the exercises, maybe skated through some of the math-heavy one, which seems like a very good choice.
Yeah, I went through all the exercises. I think that I'm trying to jump in here. Actually, let me open the right set. I was just glancing at my 2-1 exercises, which really confused today. One thing I found annoying, which I'm sure you solved in a much cleaner way than I did, was I ended up putting all the scripts in one together and had name overlaps.
Oh, yeah. Yeah, that's definitely a problem for sure.
So what do you mean by name? You mean like where the function?
So I have 7 versions of PySum. And,
yeah. I've been trying two strategies. One is to use like the name like PySum and then the name of the problem. Like especially if I want to compare two, like compare one with the output of one with the output of the other. But then the other one is just letting it override, which actually causes some weird bugs if you don't know that that's happening.
Right.
So it cost me some bugs when I was trying to solve some of the problems in the next section, and I had inadvertently. In fact, they ask you to override car or
right,
CDR.
yes.
Yeah. And then I was like, why isn't my car working? Why isn't my why isn't my CDR working the way it's supposed to? And then I was like, oh wait a second, it's just using the one I just wrote. I mean, it's literally because apparently in other versions of Scheme this doesn't actually happen. You cannot override that level of, the functions that are core level functions you can't override. So I thought it was really funny that.
Yeah, the version I'm using is giving me errors, but I guess you might be shadowing them. On which
MIT Scheme just lets you shadow whatever you want. So you can shadow car, you can shadow CDR, you can turn it into whatever. So it's really funny.
And which one are you using, Mort?
I'm using. I've been using DR Racket with the Lang Planet Neo SICP as a language modifier.
Actually, I'm surprised that the language modifier does not let you, or does it let you just overwrite things, or does it toss errors if you do that?
It's tossing errors.
Okay.
But with me it doesn't actually toss any, like MIT Scheme, it doesn't toss no errors or anything. It just lets you do whatever you want. So actually, do any of you have experience with MIT Scheme? Because I'm actually having one issue that I feel is going to kind of hurt me in the next couple of sections, which is that I cannot figure out how to enable the graphics. And I know that there's some problems that are going to come up soon that have to do with graphics, and I cannot get I can't get the graphics to work. It's really weird.
So are you looking at the libraries in 4.2.4 or whatever it is, or is there another graphic library that you're trying out?
I don't know. That's the thing. It's supposed to. Its core is supposed to come with elementary support for graphics, and I can't get that to work. I don't know whether it's because my inclination is that somehow it's because I'm using it via the terminal, which is what I usually use all the stuff in, and that graphics isn't supported via terminal. But I don't know how else to turn it on. Like I don't know if not via the terminal, then how do you turn on MIT scheme, and I've looked everywhere for this, and I think MIT scheme is old enough that not enough people, there aren't groups out there that know how it works. And
yeah, that's actually the reason that I ended up going with Racket as well, because the language extension, the Neil Van Dyke's SICP extensions for Racket, also include another library somebody else did that handles the so-called picture language,
yeah,
which is going to be used in Chapter 2.
exactly. So I'm really worried about that. I might have to switch over to.
You can also, I mean, if you don't want to switch, you can just do those few exercises in Racket if you want to. I mean, if you aren't using like Dr. Racket and you're just using the command line and you aren't using Edwin for MIT scheme,
right.
It probably is not going to make a huge difference in terms of your actual experience.
Right. So I might end up doing that, and just for those couple, we'll do that.
Oh, one other reason I ended up going with Racket is because Emacs does not do a good job of supporting MIT scheme. So the main scheme package, which is called Geyser, Geiser,
right,
has some. It's kind of flaky compared to other Lisp support. I mean, it's not a patch on Emacs like Common Lisp or Clojure support, but it only supports Racket and the Guile.
Right. I actually just wrote all my own stuff for supporting it in Vim, because there was no MIT scheme support in Vim,
Right.
So I had to just.
Well, yeah,
there was
too hard to.
Yeah, it wasn't. I mean, all I did was run, essentially an evaluator, and it's pretty easy to hook up any evaluation sort of thing to.
Mm-hmm.
Yeah.
So I think going back to the problems, as I recall, for Simpson's integration, that's the first one. I'm trying to, let me try to split my screen here an extra time so I can see yours and mine. I ended up defining 4 separate series, which to me made the problem simpler.
Okay, can you share your solution so we can have a look at it here?
Sure. How do I do that?
Excellent. So up on the left side of Google Hangout, there should be a little window with a green window with an arrow on it.
I see screen share.
That should be it.
Okay, this may be getting there. Are you seeing?
Yep, seeing it.
Okay, so that's what I did. So I don't know if that was elegant or ugly.
That's. I did something very similar, except I cheated because I read the whole chapter before I started doing the problems, and I got to the part where they talk about let.
Sure.
And so I used let.
Okay. Yes.
Because it's kind of like I almost feel like they cheat, and that's why I read everything before I start, because a lot of the times at the end of the chapters, at the very end of the sections, they will give you a better solution for doing the stuff from before.
Right.
And instead of going back and redoing that, I just want to say, okay, what is it that they're going to teach me, and then try to do it the right way from the beginning.
Right. Clearly a benefit. So I have a question on the let, but the point I was trying to make here is that I separated the Y0, the YK term, and the evens and the odds, because it just, to me, struck it as an easier way to think of the problem.
So yeah, I'm trying to see what I
Yeah, mine's pretty close to yours, Mort, except I split out the term mult into a separate function as well. So the term multiplier.
Right.
So here's my version of that.
Yeah, my version is a little bit different than you guys. I actually, oh no, I do. Actually, it's a lot more similar to yours, Paul. Except that I used let instead of defining the pieces up there.
Yeah, I was actually, since I've done a fair amount of functional programming before, I was trying to play by the rules and not use anything that hadn't been introduced. So, but cheating's perfectly cool for stuff like this. I mean, whatever it takes to get you to understand it.
Yeah, I mean, I just felt kind of like let it sort of worked in this case, so it's kind of. But I had to use let twice, like let. So let me see if I can share my screen with you guys. Sure. Let's see, how do I do that? So how do I do that? Do I click on?
It's the left side, the green arrow.
Okay.
Brings you to share screen, and then it'll pop up either which screen or which app you want to share.
So, oh, I see. It says Google Hangouts or desktop. I'm assuming desktop, and then I can move over.
Yeah, desktop's the best way to do it.
Can you guys see that I changed?
Not yet. No.
Not yet.
Okay. I guess I must not be doing something right. Wait. So you cannot see anything that I've done.
We just see you at the moment.
Okay. What about now? Can you see anything now?
You're frozen. So no.
Wait. Let me try.
Yeah,
let me try
maybe.
This again. Should I try Google? I see Google Hangouts and desktop. So which one?
If you go over to the left-hand side, it should be a green arrow sort of pointing out.
Yeah, I did that. But then it asked me to select a window to show in the video call.
And it should be desktop. Google Hangouts is just the Hangout window, so that will only share your web browser.
Okay. So when I do that, so how do I? So I have I have like 3 desktops. So which one is it? Number 1 that it's probably.
Well, yeah, that's of course an issue. This is one of the reasons I'm doing this on my laptop instead of on my desktop, because the laptop just has one screen, and Google Hangouts does not deal well with multiple screens.
Oh, okay.
However,
so you know what?
We're actually seeing your desktop now.
Oh, you are?
We are seeing it, yes.
Okay. But do you see my terminal window now?
Yes. Now we see your terminal window.
Okay. Great. So so this is my solution. It's very similar to you guys. I have a let statement for that define that you do, where I define H as the,
right,
that division, and then I have another function that defines that takes 2 parameters and then does the rest. So it's very similar to what you did. And then I can just run it here. You see that's the answer down there. This is, by the way, I've been doing these sort of assertions like that. You can see that that's true, and that's kind of like the way I solve these problems internally.
Yeah.
So my other question on the let is, what do you think of the different styles of mlet versus let in like an SML? So whether is it a benefit for the language to give you 2 different versions of a let that scopes just internal to the let, or allows you to have visibility?
I personally like the visibility. I was confused by this let because having done a bit of Clojure, that so if I define, for instance, at this level, if I define let here, then the next let, the next whatever parameter, knows what's happening above it. And so this function, I tried using both the lets in one let, but I ended up having to do 2 lets, one inside the other, because
H is invisible.
Each was invisible to the other, right? From the yeah. So
Right.
I felt that that was kind of at least in Clojure they did it correctly, I guess because they've had hindsight and realized that scoping kind of matters inside a let statement.
So just to clarify, what we're talking about is successive terms in the sort of the start of the let. We're
Right.
saying
So the first, so like when you say let A equals B, or let A be B, right, and then let C be A, that should not throw an exception, right? Because you've already defined A.
Mhm.
You know, but it seems but in at least in MIT scheme, I don't know about the schemes you guys are working on. In order to get that to work, I would have to do a let of A, B, and then inside the body of the first let, do another let, and of B A or of C A. It's
and the difference is basically one of syntactic sugar.
right.
Because you can think of the explicit form where you're sticking that second let inside the outer let. You can think that the other version, the Clojure style version, could easily be rewritten as the other type.
Right. Yeah. So it's definitely sugar, but I think it's like some sugar. I think makes things a bit more intuitive. I mean, let itself it's a sugar, right? It's
Well, and actually, for me, that was one of the coolest parts of this chapter. You know, the bit where you actually sit down and grok how let and lambda are in fact more or less equivalent.
Yeah, they're the same thing. And actually, for me too, that was kind of like I had to sort of sit down for a half an hour and try to, and, just kind of think about it. And okay, that's really interesting. So.
Yeah, I mean, as I said, I'd done a lot of functional programming before that, but that wasn't something that I'd previously really grokked.
Right.
So that for me, that was like the big new insight that this gave me.
It's interesting though that even though. I mean, I still don't see 100% the value in defining the let when I see or like when it makes the most sense to use let versus when it makes the most sense to use define. I think they talk a little bit about it, but they don't really go into the details of when it makes the most sense.
I mean, I think it's not going to be clear until they define environments and you see how environments where your declarations are scoped.
Right.
So I think as I'm trying to remember in this book if they talk of frames or environments, but
I'm pretty sure they do environments. So I haven't looked ahead a lot. I think that's my memory.
So I think it'll become more clear, but that's a case where having a language which stops you from reusing the same declarations makes it really clear. You don't want to use define any more than you need to, because you're getting things into the global namespace.
Well, in Scheme though, you are not actually getting them into the global.
Right, because it's all inside.
Compared to Clojure's def, which is different because def creates a root binding.
Mm-hmm.
But in Scheme, you're only you could say several defines inside the same lexical scope will create those names within that lexical scope. And so, in fact, that's in your version where you've got several defines in a row. All those are not visible outside of the context of the outer define, of course.
Right.
Yeah.
Right.
Good. So I think another. I don't know if this is if people are good with just jumping around. One of the things I found interesting is that sometimes I found the iterative versus the recursive and the tail recursive with an accumulator. It just was interesting. Sometimes one felt much more natural than the other. and just I was able to build all the versions. It's fairly mechanical, but it just the feel of some of them just said, "Whoa, this is like really simple
Yeah.
and easy."
I also found that it was really nice how they kind of forced you to really sort of drill that. Sort of, okay, you did it if you did it the iterative way, then do it the recursive way. If you did it the recursive way, so whatever you found easier, which is what you would try to do first, they asked you to do it the other way. And I felt that you kind of get an impression of, okay, what kind of problem is easier to do in one way versus the other way? Because I did run into that sort of situation. Most of the problems were pretty easy to do recursively, or I started to feel that they were a bit more easier to do recursively. I am an iterative person, so.
Right.
But I found that there were at least one. I can't figure. I don't remember which one, but I remember that was really difficult to do the recursive version. I think it might be the one with the NR, the one that's to do what do you call it? The one that's the fractions under the fractions under the fractions under the fractions under the fractions.
Continued fractions.
Yeah, continued fractions. I remember one of those I hit where it was like the iterative version was so easy, but the recursive version was just like so difficult. And so I was like, okay, so I don't know if I have it honed in yet, but I felt like I got a lot of practice in that sort of that's
cool, because 1.2 has you do a lot of those, that same type of thing over and over again. And actually, I think one of the cool things about 1.2 is exactly sort of that drilling process. And so then in section 3, you finally see, okay, well, we've seen doing the same thing, or related things the same way a lot. Here's how we actually turn that into this other type of abstraction, which you may not have seen before if you haven't thought about things in terms of higher order programming.
Right.
But you did end up getting the recursive version for continued.
Yeah, I actually ended up getting the recursive version. It was I don't forget what problem that was.
It's down to 137 or 138 or somewhere in there.
Yeah, I remember having a pretty hard time with the recursive version or I think I make a statement in the problem that I forget which one that I had a hard time with.
That's interesting because looking at my notes here, I did the recursive version first. So that's the one that's.
So which exercise was it? Was it 137?
Correct.
So 130. Let's see. What did I do?
Sorry, 1 second here. My cat is crying outside the door. I haven't closed that door. Moment here.
I did the iterative version first, but I don't recall.
I actually did the iterative version first. Okay, so it was the opposite experience that I had. The iteration I found more difficult, whereas usually I find iteration easier. In this problem, I found it a lot more difficult. Yeah, see, I even put the iterative version required more thinking because I needed to reverse the order of the calculations.
Okay, well, he has abandoned issues.
Oh, yeah, sorry.
Okay, so apologies for that there.
Sorry, no problem. So I take it back, Paul. I actually meant the opposite of what I just said. The iterative version was harder for me with this particular problem, which is, I think it was the first time I had a really hard time with the iterative version, where the other version was just so much easier. The recursive version was so much easier. It sort of just came out. But with the iterative version, I had to do everything in reverse, and so it was much more difficult.
Yeah, thinking about things in terms of that accumulator feels a bit unnatural at times, I think.
Well, yeah, because with the iterative version, you literally have to start at the end and work yourself backwards. That's the only way to do it, I felt, to do it properly.
You end up going in the opposite direction.
Exactly. And I think that because you do it that way, whereas, when you look at the problem, it's not in that direction. The recursive version is easier because of that, because you don't have to sort of flip the way you think about the problem.
Yeah, the interesting thing, or one interesting thing that isn't really addressed in this chapter, is there's sort of the third model, which is the one that Clojure tends to favor, which is where you're operating on lists of things. So you're more or less declaring properties on the list.
What's interesting is I think for one of the problems, I actually do that. I generate a list, and then I work on the list because I think that that works. Or I generate not necessarily a real list. I generate something like that creates a sequence of stuff, and then it was the one where I forget the problem. I think it's like 146 or something like that, where they ask you to try this with a filter, and since I know that filters can work on lists, so I create the list first, and then I pass it that, and then it filters out the. I think that yeah.
Yeah, one of the useful things about this book in general, though, is how it is trying to build everything up from first principles. So even if you've seen some of this stuff before, I mean, if you look at how a lot of those functions are implemented under the surface in Clojure, they're implemented using something like recur and loop.
Right. Yeah.
But I think the other lesson out of this specific problem is that frequently when you're stuck trying with a problem, with how it starts, you might be able to get around a problem by thinking of how it ends. So,
right.
I hit the same issue here. How do you create partial sums when you're don't have a valid don't have a well-stated formula. It's you have to start at the other end.
Right. Yeah, and that's sort of. But what's funny is that with that equation, even though the equation itself is not like quote unquote valid, the recursive solution is easy. I mean, comparatively easy. And I think that was the first time that I really was like, okay, recursion really is a lot more intuitive than iteration in some cases. Especially like with this problem, I think it was like, for me, it's like the poster child of how recursion is easier to think about than.
Yeah, it's interesting. This is sort of, I think, a good example of that wishful thinking type of thing. So you're defining your recursive call in terms of, well, this is what it should be.
Exactly.
And then we just bottom it out eventually.
And then everything works. And I thought that was okay. Well, that's fantastic. The fact that I can just do that. Whereas the other one, it took a lot more thinking to make it work properly. So.
Right. And the reason you have to go through that is because it's the piece you can't see in the process, or in what's going on behind the scenes. It's the shape of the process.
Right.
It's the point that they kept making in, I guess, either 1.1 or 1.2, where it's okay, well, this is the sort of all these pending recursive calls that are being built up behind the scenes that have to be satisfied.
Yeah, I actually think that this chapter was a lot easier than 1.2. I still haven't gotten through all of 1.2 problems.
Yeah.
So I thought that was kind of interesting that 1.2 was so much more difficult than even the next two sections. I've been calling them chapters, but the next two sections. So.
One interesting thing is that in Sussman and Abelson's comments in the teaching guide, they say that instructors may want to introduce section 1.3 before 1.2.
Yeah, in fact, I was surprised
to get
that
stuff onto the table as soon as possible.
Yeah, after reading 1.2, I mean, reading 1.3, that they even did that they made the decision to go with, I think, something as difficult as, I mean, it's not that difficult because ultimately you can come up with some sort of easy sort of ideas, like, okay, how to think about these functions, but I think it's more abstract, so it's a bit harder to understand what's going on.
Yeah, I think sort of pedagogically what they were thinking is if you look at sort of that sequence of very similar problems that you run through at near the end of chapter 1.2 that are all, okay, do this iteratively, do this recursively, and, okay, we're going to write this, and this looks almost exactly like the solution to the previous problem, but with a couple of changes. So that's sort of preparing you for the jump you make to that level of abstraction in the exercises in 1.3. And actually, I absolutely love the final sequence of exercises in 1.3. Where it just gets more and more general.
Right. Yeah, and
in fact, you get up to that last exercise.
Oh, the one that's what's that one? The
146, the generalizing iterative improvement.
Yeah, although I hated 141. Just from a naming convention.
Oh yes, doubling double. Yes, that one was.
Yeah, give me a different name for that.
Yeah, I commented that double is not a very good name. Twice would be a better description of its actual semantics.
You know what? I hadn't thought about that, but in my comment, I wrote apply twice.
Right, exactly.
Right.
Yeah, because it isn't doubling. I mean, and of course you've also got the naming collision with all the floating point numbers that everybody's used to these days.
Right. I was
6. Yeah, number 46 is pretty long. In terms of
the last one, yeah.
Yeah, because you have to kind of break up the problem into all these little pieces before you.
Yeah, but it's sort of back with that wishful thinking. They're really nice, clean, easy pieces.
Right.
But it certainly sounds like just I don't know. it's one of those sort of semi-magical. We're going to iteratively improve by you're telling me what's good enough and how to improve. It's the ultimate in deferring everything.
Right. But so they talk about trying to defer stuff. So.
Yeah, the interesting thing is you've got sort of this tension between top-down and bottom-down design in general. And so you need to understand sort of what the bottom-level pieces are in some cases. So you're looking at what type of objects or entities you're manipulating in the context of your program, and sometimes that's the best way to do things because you need to get something you can get your arms around. But in this case, it's the other way, where you're saying, okay, well, this is the these broad almost nebulous classes of types of things that we could do. And then you keep drilling them down. Go ahead.
Right, I agree with that, but I think the other open question that isn't really posed here, but is in the programming in a large sense of things. The challenge in programming is how adaptive anything is to change. So whether you're approaching the problem top-down or bottom-up, ultimately somebody else is going to take over your code and hack it to pieces. which style creates a better abstraction, a better maintainable abstraction? And I think the reality is that if you're omnipotent and omniscient, then any monolithic design you create is going to be ideal. but if you're not omnipotent and omniscient, then it's really beneficial for those who are going to take over to have some composition of really simple things, which ideally are named in a way they can find them.
Right. Yeah.
I think one of the insights that this gives as well is that you need to, before you start just creating your abstractions willy-nilly, you have to understand something about what you're going to be abstracting. Because they don't they don't start you off with, okay, well, we're going to start off with something as general as possible. And from there, we're going to, come up with all these different special cases. They approach it from the other way. Okay, well, here's some special cases. Now let's look at it and try to, draw out the different commonalities in a useful way. So, in a way that's going to help us, do not repeat yourself and give mental leverage on an entire class of problems that you already understand to some extent.
Right, and sort of, Yagni-ish in that you don't over-design for the things you don't know about yet.
Mm-hmm.
But then step back to your top-down refactoring, or something like that.
Yeah.
I was also impressed sort of the algorithm design aspect of this. Different approaches to the same problem get to results a lot more quickly. So it was sort of cool to do whatever one was, printing the interim results. And
yes. Actually, I think that's another one of the things which is kind of useful. They don't necessarily draw this out a lot. They had one in there. It's a 136 probably. I have it labeled as observing fixed point approximations. But, sort of building up, it's sort of an extension of what we had in the earlier sections where you're trying to understand the shape of the process. It's understanding, building the linkage between your intuitive understanding of what the code does with the code that's been written.
Sorry, guys, I had to go get some water.
Hey, no worries.
No problem. So the only other comment I had was in 145.
Okay, that's the repeated smoothing.
Repeated average
damping.
Yeah. So what I created was based on base 2 log of the exponent was my the floor of base 2 of log of the exponent was what I took to be the number of times to repeat the average damp, and and I got that answer. I didn't empirically derive it or analytically derive it. I Google derived it.
That's actually one of 2 problems that I did not do. I didn't do that one. I didn't do 135, which is the fixed point of phi.
So I actually did this one. I can share my solution.
Yeah, I'd like to see it.
Let's see, desktop. This was actually one of the more interesting ones, I thought. Start screen. Okay. Can you see Can you see?
See it now. Yes.
All right. So what I did. This is actually pretty long. Is this number 40? This is number 45, right?
145. Yes.
Yeah.
So apparently I defined something called multiply by. I'm not sure why I did that. And then I test to see that multiply by works the way I want it to. Multiply by x. I think mostly because I needed that function for some reason. So multiply by 2, -1 should be -2. So I think that's oops. That should work. Oops. Sorry.
Okay, so then you're using repeated multiply by as your power function.
Yeah, but then what I did was, ultimately what I did was this piece right here. I did an experiment and just see what actually is going on, and I think I realized that, let's see, root 10. I thought I did some sort of experimental results. I kind of just like by looking at the experiment, I realized the pattern that was that was happening, and then I built the function around that. So
Cool.
by empirical evidence, average damp should repeat to the last log 2n. I kind of just essentially just figured that out empirically.
Yeah, I think that was the right thing to do if you didn't take my shortcut. And you know, I found somebody who did what you did and then took the results.
Yeah. Yeah, that's pretty much. And so what I did was that I did it up to. I think I did it up to the, an assertion for like, does this thing work for this level? But I couldn't. I couldn't. I don't think I could do it any other way other than doing it sort of empirically, and then realizing from that what the answer should be.
Yeah, I don't know that there's an analytical way to derive the number of times to do an average damp.
Yeah, the interesting was that I think that I created my own exponent function.
Yeah, I cheated there too. I looked up and found there's an exponent function.
Yeah, it turns out that there was. I would have known that if I had done section 1.2, but because I hadn't actually worked on section 1.2, I didn't know that there was an exponents function. So I actually created my own, and that's why I needed the multiply by, repeat it, multiply by n times, and that's my exponent function.
Well, let me give you a hint from section 1.2 that you can make that code much more efficient if you repeat it, if you double and work your way recursively back. If it's odd, you multiply by the number. If it's even, you double the prior number, and that's how you can get a more efficient power function.
Oh, okay.
Yeah, actually, since you fought your way through these, you'll probably appreciate those exercises now if you go back and take a look at them.
Yeah. So what am I doing here? Yes, I'm not. Yeah, I'm not. So you're saying like, what you do is that you see whether or not it's like divisible by 2 or something like that, or?
Yeah. So one of the cool exercises that I believe is in 1.2, I don't remember which one, is if you want to take 3 to the 10th power or something,
right?
You can 3 to the 10th is 3 to the 5th times 3 to the 5th, which is 3 to the 4th times 3, which is
really cool.
3 squared times 3 squared. So you can recursively sort of define that algorithm.
Oh, that would have been smarter. Yeah, that would have been totally.
Well, it's why, as Paul said, it's cool to go back and do some of those 1.2 exercises.
That's exercise 116.
Yeah, I'm totally gonna go. Oh, I am gonna work myself through a 1.2 eventually. 1.2 I found it because I actually only just did the what do you call it, the form, the proof. They have a proof in 1.2. Which was actually rather difficult for me anyway.
That proof was a pain. Yes.
Yeah, so I proved that, and then I think at the end of it, I realized from doing 1.3 that the whole point of that whole thing was just to give you another way of solving for phi, for phi.
Yes, exactly.
But you would only realize that after doing 1.3. It's like, oh yeah, I know this other way of solving for phi.
Right.
So I see the right way to say it.
I normally do phi as in pi. So
Phi. Okay. Yeah.
Yeah. So Paul, you said you skipped the fixed point?
Yes, I skipped the fixed point. It is one that was on my list to go back and do. I just didn't get around to it. And
Yeah.
it's sort of been lying fallow.
And yeah, that's pretty much the reason. Yeah, and I think that with this one, I don't think as you could have gotten the right answer unless you did some experiments with it. At least
and actually that was the that I've been putting it off, because one problem with the org mode Babel stuff is that it does not deal well with non-terminating processes.
Oh yeah, because you do hit that one that does not. Yeah.
Yeah, and so it was just I was going to have to either work out a way to kill the process. It was going to have to add extra machinery beyond the problem itself.
Right.
So did you do 135, Mort?
135. Yeah, I did.
That's the fixed point. Okay.
Yeah, I did.
135.
Well, 135 is trivial. Here, I'll show you my 135 was. Let's.
Oh, exactly. That's the.
Where the heck am I?
Yeah.
1.3. Are you seeing it now?
Yeah. I'm seeing David's at the moment.
Oh, I'll get out of that. I'll stop sharing my.
No. I think if you click on mine, it'll go to it. If you click it.
Okay. Yeah, I see yours.
Yep.
Okay. So 135 was simply to apply fixed point to calculate phi.
Oh,
that's pretty cool. What feature is that with like the?
Nice.
So the challenge was 134, where you're building defining fixed point. So one thing I did was I don't know, where does this start? I'm trying to.
No, 134 or 130.
Well, here's where I'm defining fixed point. So first off, I set my tolerance much higher because I was getting tired of because the machine's fast enough these days. So I just went with a higher tolerance. But this was I don't remember if this was the exercise or just given. So I think he gave us this.
The tolerance.
Yeah.
Mm-hmm.
So the overall.
Are you guys talking about 135? Because I don't see anything about a tolerance. Oh yeah, tolerance of 0.0001 is what I used.
Yeah, I used I don't know how many zeros are in there. Tolerance of it's about 9 zeros or so.
Wow, yeah, I think it was only like 4 zeros that I used.
Right, and then I applied the fixed point for sine of y plus cos y, and I ended up in these failed to converge. I ended up commenting them out for the same reason to let the script run.
Yeah.
And then 135 was simply the function, straightforward, define this fixed point formula. F of x equal to 1 plus 1 over x.
Mm-hmm.
Right.
So,
which they pretty much tell you to do that from the beginning, like with that sort of, they ask you to show that the golden ratio can be, satisfy that function, the 1 plus 1 over x function.
Right. But it's, the whole concept of a fixed point is just a cool concept.
Yeah, I think that's a really cool concept.
So, and then I just, 136 is where it added the verbose component to it.
Mm-hmm.
Oh, there's a let. Obviously, he suggested using lets by this point.
Yeah. Yeah, this was the 35 steps versus the 10 steps. Mm-hmm.
By adding the damping. So, Yeah. Any other ones you want to look at?
I can't remember any of the good ones for some reason. I think I did this quite a back.
Yeah, we're definitely behind. We'll try to do the discussion for 2.1 maybe in a couple weeks or something here. I mean, there's not many problems for that, and
yeah,
that'll get us back on track with the other group.
Tutorial 2. Do factorials again. The the 1.33 I thought was pretty interesting in terms of. I think that was the one where he introduces the concept of a filter.
Yep, I think that's correct. Yeah.
That was a pretty long process, I thought. That one took me forever, in fact.
Yeah.
I think I have like. Oh yeah, I have a really long. It took me a long process to solve that one. Like.
Yeah, I mean, my comment on this one is that this is sort of one of the early steps in the build your own lightsaber part of the
right.
book.
I think first I come up with a way of defining prime, a function for prime, and then I apply it to a range so just to test it. Okay, prime works. So that's my filter, and then I go ahead and I use. Oh yeah, and prime is kind of just very basic. I do modulo until I figure out whether or not it'll go into itself X number of times and that sort of stuff.
Actually, there's a lot of prime stuff in 1.2 as well.
Yeah,
So
I figured that I was probably rebuilt.
Yeah, I just copied the one of the primes from 1.2.
Yeah, I felt like that this problem was so long, like every little piece, like it took forever to actually finish. But then I had something finally that worked.
Right. So one of the challenges is, you need to resurrect the prime in a GCD that was, if you didn't have it from before.
Yeah, if you had those pieces already written, this one's actually pretty straightforward. Once you just have to come up with your specification for your filtered accumulate function.
Yeah. Well, I mean, I feel like with having I guess had to do this, then when I get to it in 1.2, it'll be 1.2 will be easier for me.
Yes, exactly. Yeah, you could just take all the functions you wrote here.
Right. But yeah, that was one of the harder ones, I thought.
I think if I'm remembering what happened here, one of the challenges I ran into was I was off somewhere with my old edition 1 hard copy, which is different enough to throw some things off. So I started working there, and I was like, wait, the problems are slightly different. In fact, at one point I found a problem, and I was like, I don't know how to approach this problem. And then I looked in the current, in the second edition, and the problem no longer exists.
Oh.
Possibly others couldn't deal with it either.
Yeah, I actually just had a look online for the. I don't actually have a copy, so. Of the original book.
Well, strangely enough, I have 2 copies of the original book.
So 1.34, I thought, even though it wasn't that difficult, I thought was cute. That was the one where it was like, what's this gonna do?
Yeah.
And
the half interval method. No,
right. This is the one where it's like.
I have this one labeled as perverse self-application.
Right. Like, you have this application, this define FG as.
Oh, yeah, I remember it.
but then somebody goes in and does this. It sends a lambda function. That's the function applied to the function.
Right.
So like, what's this gonna do?
Yeah,
It doesn't. Yeah.
I think I mentioned to a couple of folks that I took Dan Grossman's programming language course in Coursera last year, and it was the first time that it really struck me that I'm used to working in languages where you can always add more clarity by throwing more parens in there. And if parens mean apply this function, then you shouldn't really use it when something's not a function or things really don't make sense. So, if you're left with 2, then you're in bad shape. Whoa, my screen is totally cool right now. Now it's back.
I think that's because I guess I still have the screen on the.
Yeah, I think if you click down at the bottom, it changes which persons you're showing.
You can lock somebody in if you want to. If you don't want it to change, you just click on their image.
Perfect. There you go.
Yeah. So that's sort of cool, just to be able to go right in and evaluate. Too, and it's right. You can apply a procedure with two. Although in many languages it says, who cares about those extra parens?
Right. I mean, I actually think that the parens are kind of a hassle, but I do see the value in them in terms of the whole. What's the right iconicity? That's not the right word. Where everything's the same. What's the
homo-iconicity?
Yeah, the homo-iconicity. So in that respect, I think it's pretty interesting, but it's still. I mean, I think that human beings aren't really meant to be seeing that many parens.
But part of what this shows is that Lisp is always requires parens when it's needed and won't accept a paren if it isn't needed.
Right, but I mean, I get in a lot of trouble with the parentheses in that sometimes I end up putting something out on the outside and versus the inside, so I keep making those kinds of mistakes.
Yeah, that's a classic as you're crossing languages, putting the it's
right.
Function name open paren or open paren function name, and you're
more like this, like if I let's say I have a function. Let's say multiply by 2, 3, 4. This doesn't really make sense, but all right. So inside that, and then let's say I also multiply by something like plus 2, 3. But the thing that I have issues with is that when these parens start getting more, right? So now let's say that I'm actually minus, I know, like all this stuff. Okay. So put that in there. That I meant to put this 4 in here. Or whatever. Sorry.
Yeah, when you start getting nested deeply,
what I mean, like
that, I tend to try to split it by lines, so you're lining up the same level of things.
But I mean, the thing is that the thing that happens that even when I do that, sometimes, I'll like do that and whatnot and start doing that. But sometimes, even when I do that, I just kind of lose track of what paren is doing what where, and that's the sort of issue I have with parens. And it's very easy to make a mistake like this. This is not this doesn't give this example I'm giving doesn't give it justice to the sort
no,
of
I understand exactly what you're saying.
Yeah.
And I think it's
let me see if I can find one here that I think for instance with these assertions it comes more often. Like so often like with these assertions that I'm making, I'll do something like where I'll skip this, right, and I'll put whatever here, something in here like this is my statement, and and then this will fail, like this whole thing will fail because I put the thing in the wrong paren. Like it's like that sort of thing. Like I don't know if.
So
I mean,
does your editor handle the indentation correctly? So if you hit return on the line, will your Vim setup stick it at the appropriate indentation level?
Yeah, it does. So like if I go here and it does that, it'll actually do it at the appropriate one. But even this one doesn't really quite give it justice. There are some sums where the indentation is not enough to know like.
Right, but part of that is not having strong typing, so you're not going to get as much guidance in, how well in poorly formed statements. And there's a trade-off the other side. I sometimes I appreciate and sometimes I just hate the syntactic sugar of Scala or Ruby to say, here's all the times that parens are optional when you call function.
Right. I mean that is kind of especially with Ruby. You're right. Like you can go in the opposite direction. You can get just as it can become just as frustrating, because I know that Ruby. I have that issue with Ruby as well, where it's like, sorry, how do I unshare my screen?
Just click on that button and that should unshare it.
Just click on the what?
On the share button.
I did. The green button, and it's doing nothing.
No, that should unshare. Your screen may be locked, though. If you click at the bottom panel, you may lock in a specific person to show.
No, it shouldn't. He's still showing you as
right.
His screen.
Ah,
so
I seem to be showing.
If you click on that screen share button, does anything come up?
Just the word screen share, but that's it. But nothing else. It's like it doesn't let me do the screen share.
Are you clicking on my screen share or your screen share?
I wonder whether I think somehow I'm clicking on your, but how is that even possible?
Yeah. Go to the.
How am I clicking on your screen share?
That's the power.
Well, because yeah.
Wait a second. I mean, I think you're right. I think I'm clicking on your screen share. It doesn't make sense.
Yeah, actually, I'm not sharing my screen at the moment.
Yeah.
It looks like there's nesting coming through.
Yeah, send backwards and then click on screen share.
Like, what's send? Yeah, I mean, nothing.
Yeah.
Let's just say I'll just keep it on screen share for forever.
Okay.
Yeah, I'm seeing an overlay of two.
Well, you're seeing what I'm like because I'm screen sharing. You're seeing whatever. So like right now, you're seeing yourself because.
Right.
Like
maybe we should start talking about Gödel Escher Bach and strange loops.
Right. All right. So. Well, that was fun.
So I think the net of this is that there isn't an absolute solution to the respect for parens. But I think that every language sort of has styles of errors that programmers make with it.
Right.
And recognizing what kind of problems are there is useful, and how compilers or linters or any other tooling can help you recognize and avoid those problems.
Right. I mean, and clearly, like the biggest problem in any programming language is writing functions that are too long. So.
If you're getting super deeply nested, that may be a thing.
So, but I mean, the parens, I think, unfortunately, I think they do get in the way of understanding what's going on sometimes.
Well, that is one of the advantages of Clojure. that there's a little more syntactic variation. Everything isn't parentheses, so that helps break things up visually a little bit.
Yeah, in fact, I think I like that about Clojure versus
but I have to say, one thing about this style of language that I really appreciate is that there is always one syntactically correct indentation for your code.
Right.
So like in Python or Haskell, where, and if you're in your editor and you hit tab to indent the line you're on, you have to potentially go through like 3 or 4 different indentation levels, and you have to have the cognitive overhead of thinking, okay, this is where this line has to be because it's with this, it's with the second level if, not the lower if, and so on. And if you paste it somewhere else, you have to make sure that it's pasting in a syntactically correct format. And if you're using a tool like PairEdit or Smart Parents and Emacs or whatever Vim's equivalent is, and you're actually manipulating entire symbolic expressions, I have found that to be a huge win in terms of sort of lowering my mental burden dealing with the parentheses, because they make it much easier for my editor to handle them for me.
Right.
In a way that it wouldn't work in a language like, say, C or Java, or something that's a little more spiky like Ruby, or is just totally loaded down with special cased things like Haskell.
Right. I've never looked at Haskell.
Haskellites might disagree with that characterization, but there are a lot of overloaded operators in there. Not technically overloaded, but a lot of operators that are very sigilly and have sort of hidden semantics to them.
Well, before David drives himself insane.
I am driving myself insane.
I can tell. I think we sort of covered all of 1.3.
I think so.
Yeah. See. Yeah, I'm actually pretty happy with the progress we're making. I actually been telling everybody about this book that I can convince that this is the book to read, but unfortunately not everyone's really paying attention.
Yeah. It's kind of a hard sell.
But it's an addictive book, and it's especially with I think that I'm going to be really excited to talk about the 2.1 exercises, because there are 2 in there that are just mind-blowing in my opinion.
Mm-hmm.
It'll be nice to get to that.
I think I know the 2 that you're talking about.
Yeah.
The church numerals and whatever the one before it was.
Yeah, the church numerals. I think that day when I did them, I was just kind of just walking around, just going, "Wow, I just cannot believe that you can do that with computers."
Yeah. And the other one's probably the alternate representation for integers.
Yeah, and the funny thing is that I just don't even have the words to explain it to people, because it's kind of like, okay, yeah, so it's an integer, yeah, it's 1, it's 2, what's the big deal? It's just but it's such a basic idea. Think about it. It's 1, and you can say it in a completely different way. I was just blown away by that.
So on an unrelated note, I looked at one of the footnotes about the source of car and cdr, and I actually tried to find the instruction set for whatever it pointed to, 704 or such, and couldn't find any. I found an incredibly cool MIT guide to using the 704, which was written by McCarthy, with handwritten notes on the copy that you found in the search, but they didn't have car or cdr as instructions.
I think you might be able to find something on Wikipedia on this.
Yeah, but I was looking for the source instruction set document.
The actual, yeah.
So I'm glancing at something on Wikipedia now, which is funny just in its in the very names. It talks about the performance of the series of 700 and 7,000 series machines. And it states, these machines all predate performance measures such as whetstone, drystone, Linpack, or Livermore loops. but you had Gibson and Knight measurements, and the Gibson measurements are in kips,
Very nice.
thousand instructions per second, and for a 705, it's 0.5 thousand instructions per second.
Yeah, that's fast. That's faster than you can do things. That's 1,000 times faster than you can do it.
It certainly is.
Yeah, that's slow. That's really slow.
It's just amazing that they conceptualized and built the initial Lisp.
Yeah, I read something not too long ago. It was like by that guy who's the CEO of Stack Overflow. I forget. He has a blog, something with I think Coding Horror. He has the Coding Horror blog. I forget his name. Yeah. But he actually has a blog post on the speed of computers today, and comparing it to light speed, and it's just phenomenal how fast of us. Like when you actually put it in terms of distances of using like the distance from here to Pluto, for instance, or the distance from here to Saturn. That's how fast these things are. They're just like phenomenally. They're just so fast now that I don't think we can conceptualize it really well. You're looking that up, Paul?
Yeah, I'm trying to find it here.
Yeah, let me see if I can find it. Coding Horror. I think it's his latest one, like Pluto disk space distance. The infinite space between words, I think that's what he called it.
Okay.
Yeah, this is the. But this is just conceptually, like if you start thinking about how fast these things are today.
Yeah.
The computers seem to work really fast, but I still think that human computation is way faster. It's probably we're just doing a different type of computation. It's not as easily applied.
Yeah, certainly for certain types of associative operations.
Yeah.
I mean, even thinking about how you might write algorithms of that sort, there still isn't a good grasp on it, even with these systems that are attempting to, mimic the structure of the human brain. I mean, IBM's been doing a major project along this.
I had this weird sort of realization the other day. You know how they talk about the what is it they call it? Not the event horizon, like. The time when the
singularity.
The singularity point, yeah.
Mm-hmm.
The singularity point. I had this idea that it's not going to be a machine that's gonna sort of have awareness. It's going to be some Borg-like thing, some combination of machine and organic brain structure, because I don't think they'll ever get machines to be able to do the things that brains can do. I mean, they probably will eventually. Maybe the machine will be able to do it. But
well, I'm going to leave you guys to solve that problem.
Okay.
And decide whether that's a good thing or a bad thing.
It's a bad thing.
I found I just sent the link to the Shipman article. Unfortunately,
Okay, awesome.
It's behind the ACM firewall. So I think I have an old copy somewhere. If it's as I said, it's a really fast read, and I'd be fascinated to look at it again. I don't think I looked at it for 20 years or at least. And scarily enough, the first time I read it was 30 years ago.
Okay.
But,
oh yeah, redirecting you to DL citation.
Oh, that's a pain. And
No.
since I graduated, I've lost my my library access to all the databases. So I'm hoping my next employer will get me access to them.
But I seem to have access to this. How come I have access to it?
Do you actually have access to it?
Oh,
I think it's a by article there.
Oh, by article. Yeah, I guess I don't. Okay.
Yeah, by this article. So quite often for modern stuff, if Google Scholar is pretty good at cross-referencing if an author has posted something on their site somewhere. So often you can scare up a PDF, but not of everything.
Okay. All right. Well, thank you guys for.
Yeah, thank you.
Thank you.
Discussion. So.
And Paul, thanks for working through the logistics challenges.
Oh, yeah. And they seem to change a little bit each time.
That's probably based on their having such clean functional code that they can change it so rapidly.
Right.
All right, I'm going to figure out how to get out of here. I think I'm
I
just
have to do the same thing. I feel like my screen
the
is going to
little
be shared forever.
The little red hang up button at the top should end
All right,
it. So.
bye guys. Thank you so
All
much.
right, thank you. Bye.
Thanks a lot.
Bye.